Alright everyone, so in this problem we have a 2,000 kilogram elevator that's in free fall, and it's traveling at 8.5 meters per second when it's 15 meters above the bottom of the elevator shaft. There's a safety spring that's located 3.2 meters from the bottom of the shaft, and it's meant to compress in such a way that the elevator will come to a stop before it hits the ground. So we want to know what should be the spring constant of the spring. So here we just have the elevator falling. It's going to hit the spring, and then the spring is going to compress 3.2 meters. Now this problem is different from the last one because we're going to have to account for the length of the spring. The spring is going to compress all the way down in a perfect world, if you will. So when we set the potential energy to be equal to 0 at the point where the elevator reaches the spring, we have to account for negative potential energy when it reaches the ground. In the last example, we would have assumed that the compression was less than the length of the spring, and so because of that, we didn't have to account for that amount of potential energy, that difference in the amount of potential energy. In this one, we do have to account for that difference, and you'll see that in the problem. So again, we're going to use energy conservation. The spring is not initially compressed, so there's no initial spring potential energy. And the elevator is going to come to a stop, so there's no final kinetic energy. So initially, it's 11.8 meters above where it meets the spring, and it's traveling at 8.5 meters per second. When the elevator comes to a stop, the spring will be 3.2 meters past the 0 point of potential energy. So we have to account for that. So the final height will actually be negative 3.2. So here we're just solving for K, the spring constant. And so we find the spring constant to be 71,533 newtons per meter.